Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0105-17 indicates a high voltage condition in the Manifold Absolute Pressure MAP sensor circuit. This code is crucial for determining issues related to the engine's intake manifold pressure readings. The MAP sensor is responsible for measuring the pressure within the intake manifold, which is imperative for the powertrain control module, PCM, to calculate the optimal air-fuel mixture for combustion. When the PCM detects that the sensor's output voltage exceeds the predetermined threshold value, it triggers this error code and stores it. This situation could adversely affect engine performance and emissions efficiency. It's essential to understand the components involved, such as the MAP sensor, which is usually located on or near the intake manifold, and the PCM, which interprets sensor data to adjust engine operation accordingly. The error description for DTC P0105-17 states that the MAP sensor output voltage is higher than an expected or specified value. This abnormal condition is detected by the PCM, which is the electronic control unit that manages engine functions. The role of the MAP sensor is to gauge the pressure inside the intake manifold, feeding this critical information to the PCM, which uses it to optimize engine performance. The MAP sensor is generally situated on the intake manifold or in close proximity to it, allowing it to accurately measure manifold pressure. When the voltage exceeds 4.49 volts, the PCM registers this as a fault and sets the DTC. The detection of this fault can lead to suboptimal engine functioning, necessitating prompt diagnostic procedures to identify the root cause of the high voltage reading. Several possible causes can lead to the setting of DTC P0105-17. First, a faulty MAP sensor is a primary suspect. If the sensor itself is defective, it may produce erratic or incorrect voltage readings. Second, wiring issues such as shorts or open circuits can disrupt the normal signal transmission from the MAP sensor to the PCM. These wiring problems can lead to the sensor output being incorrectly interpreted by the PCM, triggering the error code. Lastly, if both the MAP sensor and wiring are functioning normally, a malfunctioning PCM could be the root cause. The PCM could misinterpret valid sensor outputs, indicating a high voltage where none exists. Identifying the precise cause requires systematic testing of each component involved in the MAP sensor circuit. When DTC P0105-17 is set, several symptoms may manifest. One of the most noticeable symptoms is the illumination of the check engine light on the dashboard. This warning alerts the driver that there is an issue that requires attention. Additionally, drivers may experience poor engine performance as the engine management system is unable to optimize the air-fuel mixture due to erroneous readings from the MAP sensor. This poor performance can manifest as stalling or hesitation during acceleration. Another potential symptom is unusual fuel consumption. If the PCM cannot accurately calculate the necessary fuel delivery because of incorrect pressure readings, this can lead to inefficient fuel usage, causing the vehicle to consume more fuel than usual. Addressing these symptoms promptly is essential for maintaining optimal engine function and emissions levels. In the first troubleshooting step for DTC P0105-17, the technician should power up the vehicle to the on mode. This action prepares the vehicle's systems for testing and allows the technician to access diagnostic tools. The next component of this step involves checking the high-definition system, HDS, for the MAP sensor voltage reading. If the HDS displays a MAP sensor voltage value exceeding 4.49 volts, this confirms the presence of the malfunction corresponding to DTC P0105-17. The HDS serves as an advanced diagnostic tool that allows the technician to examine real-time data from the vehicle's systems. Taking these measurements is critical, as it provides the necessary information to move forward in the troubleshooting process. In the second troubleshooting step, the technician should first disconnect the map sensor connector. This step is crucial to ensure the accuracy of the following tests. After the connector is disconnected, a jumper wire should be used to bridge terminals number 1 and number 2 on the map sensor connector. By performing this action, the technician can check the output of the map sensor system independently from the sensor itself. With the jumper in place, the vehicle is again turned to the on mode, allowing the technician to observe the HDS for the map sensor voltage reading. The purpose of this step is to confirm whether the issue resides within the map sensor or if it lies within the related wiring or the PCM itself. This diagnostic approach is methodical, ensuring all components are assessed accurately. Moving to the third troubleshooting step, the technician must prepare for an open wire inspection. The MAP sensor connector must remain disconnected, as should the PCM connector. This ensures that there is no interference during the testing process. The technician should investigate the PB and SG1 circuit wires for continuity and proper connection. This inspection is crucial, as open circuits or shorts can cause incorrect readings, resulting in DTC P0105-17 being triggered. Using a multimeter, the technician should find that both the PB and SG1 circuits have resistance measurements of less than 1 ohm, indicating a healthy circuit. If higher resistance readings are found, this suggests that there may be issues in the wiring that requires rectification to restore the correct circuit function. The final troubleshooting step involves inspecting the PCM itself. After completing all previous checks, and if they returned normal results, the technician may conclude that the PCM is the likely source of the issue. A malfunctioning PCM can lead to erroneous interpretations of sensor data and can generate false DTCs. In this step, further investigation into the PCM is necessary, potentially including checking for software updates, inspecting for physical damage, or verifying connections. If a fault is identified within the PCM, it may need replacement or reprogramming. This step highlights the importance of a systematic approach, ensuring that all other components have been ruled out before concluding that the PCM is at fault. After completing repairs associated with DTC P0105-17, it is essential to perform final verification to ensure that the issue is resolved. The first action is to clear any DTCs stored in the PCM using the HDS or other compatible diagnostic tools. This step is crucial as it allows the testing of the system without the influence of past codes that may still be stored. Following this, a test drive should be conducted to monitor vehicle performance and verify that the issue has been rectified. During the test drive, observing engine behavior under various conditions will help ascertain that no symptoms reappear. If the check engine light remains off and the vehicle operates smoothly, it signifies that the repair was successful. This verification process completes the troubleshooting protocol and assures thoroughness in resolving DTC P0105-17. To prevent the recurrence of DTC P0105-17 in the future, preventive maintenance is key. Regular inspections of the map sensor should be performed to ensure it is functioning correctly. This includes checking for any physical damage or signs of wear that could affect its performance. Moreover, periodic checks of the wiring and connectors related to the map sensor are essential. Ensuring that the electrical connections are clean, secure, and free from corrosion can greatly reduce the likelihood of circuit-related issues. Staying proactive in vehicle maintenance not only extends the life of components, but also prevents costly repairs associated with diagnostic trouble codes. Establishing a routine maintenance schedule will help keep the engine operating at peak efficiency. In conclusion, DTC P0105-17 indicates an issue related to high voltage from the Manifold Absolute Pressure MAP sensor circuit, which is critical for optimal engine performance. Throughout this troubleshooting guide, we've explored the roles of both the MAP sensor and the Powertrain Control Module, PCM, and how their correct interactions influence vehicle functioning. We've outlined systematic diagnostic steps necessary to isolate the issue effectively, including validating sensor function, inspecting wiring, and ultimately assessing the PCM if other components are confirmed to be functional. Furthermore, implementing preventive maintenance practices can help avoid similar issues in the future, ensuring the longevity of the vehicle components. Understanding these aspects empowers technicians to address issues promptly, maintaining vehicle reliability and performance. Please like and subscribe to the channel. See you next time.